Hi, this is Mr. Sapone, and today we're going to look at balancing chemical equations. And the guiding principle here is the conservation of mass. We can't create or lose atoms in a chemical reaction. So when we have reactants combining and they're yielding products, we kind of have to have this, not kind of, we have to have the same number of atoms on each side of an equation. So we see here that this equation right here would not be balanced. Two A atoms combine with two B atoms to produce the, say, molecule AB. And again, we only have one A atom over here, but we started with two. So what happened to this other A atom? And here we have two B, but only one over here. And we generally can't lose or gain atoms in a chemical reaction when we're dealing with formulas. We have to keep track of all of them. So a balanced version of this would be 2A plus 2B forms 2AB. And this would be a balanced chemical equation. And we're going to balance a bunch of chemical equations. And it is kind of the process, the idea behind it is this simple, but it does get a little bit complicated as we look at some challenging chemical formulas. And let's look at the formation of water. We know that water is H2O. So we have hydrogen and oxygen combining to form water. So write and balance this equation. Well, some of you may be inclined to think that, well, H2 plus O is going to form H2O. And this equation would be balanced because we have two hydrogen here, one oxygen here, and one here. You have the same number of atoms on each side. There is going to be one problem with this, though. And if we remember this saying that we have posted above the faculty lounge, I wish, have no fear of ice cold beer. These are the 7 diatomic gases: hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. All of these elements are going to exist in pairs. Like if you had a bag of oxygen, the vast majority of that oxygen will be bonded together with itself. It will be O2. Oxygen by itself is going to want to combine with another oxygen to be stable. Same thing for hydrogen, nitrogen, fluorine, and so on. So all of these diatomic gases are going to exist in this form. So the first thing we would write is an equation like this for the formation of water. H2 plus O2 yields H2O. And we see this is not balanced. There's two hydrogen on both sides, that's balanced, but we have two oxygen here and only one over here. Or two oxygen here and only one over here. So how do we balance this equation? Well, the first thing is to count atoms, and we kind of did that already. There's, on the left side, we have two hydrogen and two oxygen. Two hydrogen, two oxygen. On the right, two hydrogen, one oxygen. And we have to balance equation by changing coefficients. Notice that all of these have a coefficient of 1, we just don't write it. So we're saying 1H2 plus 1O2 yields 1H2O. But you can change these. You can make this a 2, make that a 4, and so on. You can never change these. Don't change the subscripts. We balance equations by changing the coefficients. Only by changing the coefficients, and let's see what that means. So I put a 2 here in front of the H2O. Why? Well, initially, I had two hydrogen and two oxygen here. I didn't have enough oxygen on the right side of the equation. So I put a 2 in here to give me another oxygen. So let's count atoms again. We didn't do anything to the left side, so the left side is going to stay the same. How many hydrogen do we have on the right side now? Well, now we're going to have 4 hydrogen, and we're going to have 2 oxygen because this 2 applies to everything. So if we were to count atoms, this is what we would end up with. And of course, looking down here, now our oxygen is balanced. 2 oxygen, right? 2 oxygen with 2 applying to 2 oxygen. Unfortunately, the hydrogen isn't balanced now. Now we have 4 hydrogen on this side because we have 2 water molecules. And we only have 2 on this side. So what can I do to get more hydrogen on this side now? Well, I'm going to change this coefficient. And I made that a 2. And if we count atoms, we now have a total of 4 hydrogen over here. 4, right? All these. We have 2 oxygen on the left, 2. And how many hydrogen on the right? Well, we have 2 H2s, which is 4. 4 hydrogen. And we, of course, have 2 oxygen. So we are now balanced. So the actual formula for the formation of water, the chemical formula, is 2H2 plus O2 is 2H2, or yields 2H2. That's the balanced molecular formula. And we're going to do a slew of problems like this, and you'll be very good at it. For now, we're going to look at another one. Ethylene and oxygen form carbon dioxide and water. So if we combine ethylene and oxygen, they're going to yield carbon dioxide and water. And of course, carbon dioxide is CO2, ethylene is C2H4. So the first thing we want to do is we want to count atoms. We need to balance this. It could already be balanced. Carbon, we have 2 on the left. How many on the right? Well, only 1, because this 2 only applies to the oxygen. Hydrogen, we have 4. Over here, only 2. So we see this equation already isn't balanced, and we're going to have to change some things. When all is said and done, this is what it initially looks like. 2 carbon, 1 carbon, 4 hydrogen, 2 hydrogen, 2 oxygen over here. And on the right side, we have 3 oxygen because there's 2 here, and there's another one here. So 2 plus 1 is 3 oxygens. And we're going to need to balance this somehow. Immediately, I see there's more carbon on the left than the right. So I can come over here and just add a 2 to this. And then recount some atoms. And when we do this, we have 2 carbon on the left still. The left didn't change, right? All these left are still the same. We didn't do anything to it yet. What we changed was the CO2. So how many carbon do we have on the right? Well, now we have 2. 2 carbon. How many oxygen? 2 times 2, we have 2 O2s, which is 4 oxygen, plus another oxygen over here, which is going to be 5 oxygen on this side. 5 O's. And hydrogen, we still have 2. And again, we're still not balanced yet. We're still not balanced. So what am I going to do now? Well, I'm going to put a 2 in front of the H2O. Why? Because on this side, I have 4 hydrogen. On this side, I only had 2. So I need more hydrogen over here. So I'm just going to change the coefficient. And let's again count atoms. We now have, on the left, we haven't changed anything on the left. So we have 2, 4, 2 still. On the right, we didn't change any of this, so we have 2 carbon and 4 oxygen. Now let's just do carbon first. We have 2 carbon right there, right? Carbon's done. How many oxygen do we have? Well, we have 4 here. And now we have 2 over here. 2 H2O molecules. So 4 plus 2 is going to be 6 oxygens. And we have 6 oxygens over here. And hydrogen, 2 times H2, which is going to be 4. Is this balanced? Not yet. What are we missing? We have 2 carbon. 2 carbon, that's balanced. We have 4 hydrogen with 4 hydrogen. 2 carbon, 2 carbon, 4 hydrogen, 4 hydrogen. We only have 2 oxygen over here. 2 oxygen. And we have 6 oxygen over here. So how are we going to balance this? Well, I think we can just kind of put a 3 here. And that should balance our equation out perfectly. And it does when we do that. And notice that I erased this little 2. This balances perfectly when we write the formula as C2H4 plus 3O2 yields 2CO2 plus 2H2. And again, it's just an idea of counting atoms. The atoms on the left of each type must be equal to the atoms on the right. We can't gain or lose atoms in a chemical reaction. And sometimes you just have to play with these. You have to just keep changing subscripts until you get what you want. And the way I recommend doing it, and the problems do get a little complicated, is creating a table like this. Count atoms on each side, and as you change the coefficient, make a new row where you're recounting the atoms and you're keeping track of what you got. You may be able to do a lot of these in your head, that's fine, but sometimes the problems get a little more complicated and it's easier to keep track of things if you sort of make a grid. This might be too much work, drawing every element out in terms of a seesaw. But a little table or even a roughly drawn one might help you balance equations better. So remember, we always change the coefficients. We're counting atoms. We're changing the coefficients to make the same number of atoms on each side of a formula. And of course, you have an assignment. Basic idea, reactants must equal products. Atoms of each element on the left equals atoms of each element on the right. Change only the coefficients. Only the coefficients. Never the subscripts. And that's the leading coefficients. Use a table if it helps. I recommend this. And remember the diatomic gases, the 7. These always are going to exist as either H2, N2, and so on. So if something says it's combining with oxygen, that means O2. And your assignment's relatively simplistic. There is a physics simulation with these 3 problems you have to do. You essentially just have to balance these 3 equations. N2 plus H2 yields NH3, that's ammonia, separating water, and we're combusting methane, which is CH4, plus O2, that's the combustion process, into water and carbon dioxide. So I want you to just balance these 3 equations. There is an app for this. You could actually click it and look at it. It'll give you kind of like a seesaw kind of thing if you're having trouble with it. But basically change the coefficients until the atoms balance. And hopefully this helps you balance chemical equations. This is Mr. Sapone. I'm out.